All right, guys, we're on day 2 of section 6.1. So what I want to draw your attention to first is, you know how we've been talking about this restriction nonsense for inverse sine, cosine, tan? I have the quadrants here. This is just a little snip from your textbook, and it has everything kind of listed. What's the domain? What interval are we looking at in terms of the range? And then what quadrants does that mean? So keep that stuff in mind. We talked specifically yesterday about sine, cosine, tan, but here are the cotangent, the secant, and the cosecant ones. What I want to draw your attention to here are the fact that sine and cosecant are the same, and cosine and secant are the same, but these two are different. Okay, so just make special note about how tan and cotan, those do not go together like the other four do. So just keep that in mind, and that's going to help us. We're going to do something today that's going to be a little bit familiar with what we've been doing last couple chapters also. But these are evaluate the expression without using a calculator, and they look kind of messy. They have a lot of different trig functions within each question, but I'm going to show you a trick to make it a little bit simpler for you. So first of all, what I want you to do is look beginning on the inside of the parentheses here. We're given an inverse tangent question and a positive fraction. So first of all, looking over at our chart that we have over there on the top right, we know that tangent is positive in quadrant 1. So what that means is I'm going to draw a triangle in quadrant 1. And I'm going to use the tangent of 3 over 2. So remember that tangent is y over x. So that means my y value is 3, my x is 2. And what I can do is solve using Pythagorean theorem. 9 plus 4 is 13. So now I have this triangle drawn just using this tangent part of the question. And now that I have my triangle drawn, I can answer any question that they give me. So therefore that means that the sine of this triangle is 3 over radical 13, which is 3 radical 13 over 13 if you rationalize. Okay, so step 1, identify the quadrant, and just keep in mind that we are on restricted quadrants over here. I'm looking at this based on what's inside the parentheses here. So tangent is positive. I'm looking over here at tangent. I'm in quadrant 1 and 4. Well, I know it's negative in 4, so that means since it's positive, I'm in quadrant 1. Draw a triangle, and then figure out what the sine is. I could have also asked you what's the cosine or the secant or anything like that. So now that you have the triangle drawn, you can answer any question they ask, okay? Same thing for number 2. We are given, let me show the chart here also, we're given a cosine problem that is negative. And so looking over here, our cosine is in quadrant 1 and quadrant 2. Well, I know in quadrant 1 it's positive, so this must be in quadrant 2. Quadrant 2. So what I'm going to do is draw a triangle in quadrant 2. And then, again, I'm ignoring this right now. I'm only working on the inside of the parentheses here. So what I'm going to do is label my triangle with X and R. Oops. X over R. The X value is negative 5 because it's quadrant 2. Radius is always positive. That's 13. And Pythagorean theorem, this is 12. It's positive because I'm in quadrant 2. So now I can answer tangent. I'm just looking at my triangle is opposite over adjacent, so negative 12 over 5. Okay, let's try a couple more. This one is pretty weird. This is kind of 2 questions in one. So do you recognize this first of all? This is going to be a little bit crazy, but this is going to be the same formula of cosine of A plus B. And the weird thing is that A is this stuff, which I know is really weird, but we're going to draw a triangle for it, and it's going to seem way easier. And B is this stuff. So yeah, same formulas that we just had our test over. I'm going to start by writing the formula for cosine of A plus B. That's cosine A, cosine B, sine switches, sine A, sine B. And I need to first draw some triangles because then I'll be able to do sine or cosine or whatever the question's asking me for. So again, when tangent is positive, looking up at the chart, we are in quadrant 1 there. And when sine is positive, this is a separate triangle also in quadrant 1. Okay, so I'm going to make a triangle in quadrant 1 for triangle A. I'm also going to make a triangle for this B thing. Okay, and I'm just labeling them A and B so that I can keep track. The A is my red situation and the B is my blue situation, okay? So if tangent is radical 3, that means the y value is radical 3, the x value is 1, and by Pythagorean theorem, that means that I have 2 here on the hypotenuse. Go ahead and pause the video and check my math on that if you like, but you square 1, you square radical 3, and square root the answer, and you get 2. And then same thing for sine. Remember that sine is y over r, so that means 1 and 3 here, and that means 2 root 2 on this. And I'm in quadrant 1 in both of these triangles, so everything's positive here. Okay, so now that I have these two triangles drawn, all I have to do is apply my formula. So cosine of A, I'm looking up at my A triangle. The cosine is 1 over 2. 1 over 2. And then cosine of B, I'm looking over here at my B triangle, 2 radical 2 over 3. And then same thing for sine of A, I'm just looking up at my A triangle, that's radical 3 over 2. Sine of B is 1/3, and I have a little bit of simplifying I can do. This is 2 radical 2 over 6 and radical 3 over 6. So 2 root 2 minus root 3 over 6 is my final answer. Okay, so I know it looks really weird, but this is just cosine of A plus B, and you have to draw a triangle for this A stuff, which is here, and B, which is here. What you have to pay close attention to is what quadrants are we in. And I have it up here so you can kind of use a little cheat sheet. These are your quadrants. If you want, maybe this would be a good thing to add onto your unit circle if you still have room. We're going to have a lot of formulas for chapter 7, our last chapter of the semester, but this would be a good thing to add the inverse function and the quadrants maybe onto that unit circle so you have it handy. Okay, this one is also similar to another formula. What I want you to be really aware of is this number 2 right here. And so what this is it's going to be the same thing as a tangent of 2 theta. But my theta is something that looks kind of weird. The theta is this arc sine 2/5 thing. So again, what I'm going to do is draw a triangle, and when sine is positive, I know that I am in quadrant 1. And so I'm going to draw. And so what I'm going to do is draw a triangle in quadrant 1. Sine is y over r, so this is 2, this is 5. That makes this 21 using Pythagorean theorem. And so I have a formula for tangent of 2 theta, or 2a, or 2x, or whatever you want to call it. It's tangent of theta times 2 over 1 minus tangent squared theta. Okay, so there is my formula, and all I'm doing is looking up at this triangle right here, and I am going to apply that triangle using the formula. Okay, so 2 times tangent of theta is 2 times 2 over root 21, and then 1 minus 2 over root 21 squared. So algebraically, this is going to be a little bit tough to simplify. This is 4 over root 21, and then the denominator is going to be 1 minus 4 over 21. What I'm going to do here is rationalize my numerator, so it's 4 root 21 over 21, and this is, when I simplify, 17 over 21. Your 21s are going to cancel when you flip and multiply, so our final answer is 4 root 21 over 17. Okay, so again, algebraically is kind of where it gets a little bit hairy on that example, but the new stuff in terms of the trig is not the formula, because we already knew that, but it's drawing a triangle out of this given information. I just dropped my 2 straight down here. It's still right there, and then that just helped me recognize the formula. I wrote the formula, and I used this triangle in order to plug in what I knew for theta. Okay, let's do just a couple more. Let's look at this one. Again, where is the tangent positive? This is in quadrant 1. I know you're thinking, are these always in quadrant 1? Not always. We'll get to an example where it's not. But this is cosine of 2 theta. So again, remember we have this 2 here. Don't lose that. But the theta is this arctan 4/3 thing. That's what I'm going to draw my triangle out of. Again, I'm in quadrant 1. And my tangent is 4 over 3. Remember, that's y over x. And that gives me a 5. There's a Pythagorean triple for my hypotenuse. And cosine of 2 theta, you do have 3 different formulas that you can use. First one that comes to my mind is cosine squared theta minus sine squared theta. Doesn't matter which one you use, you will get the same answer whichever one you use. But the cosine squared of theta is 3 over 5 squared. And the sine of theta is 4 over 5 squared. So remember, that makes it 9 over 25 minus 16 over 25. And that gives us negative 7 over 25 for a final answer. Okay, last one I want to look at is this one. Again, I have a tangent of, I'm recognizing this formula as A minus B. And my A is this. I'll draw a triangle with that. And my B is this. I will draw a triangle with that. So let's figure out what quadrants we're in here. The cosine is positive in quadrant 1. The sine is negative in quadrant 4. Okay, so that's looking up at the chart. Sine is restricted to quadrants 1 and 4, and in 1 it's positive, so in 4 it's negative. So I'm going to draw these 2 triangles really quick. This is my A triangle, so cosine radical 3 over 2, that makes this 1. And then in quadrant 4, this is my B triangle. The sine is negative 3 over 5. That makes my x value 4 by Pythagorean theorem. What I'm going to do is apply my tangent A minus B formula. That means tangent of A minus tangent of B over 1 plus tan A, tan B. So tangent of A, looking at my A triangle, 1 over root 3, which is the same thing as root 3 over 3. Looking at my B formula for tangent of B, negative 3 over 4. Yes, that's a double negative. I'll change it in a second. 1 plus root 3 over 3 times negative 3/4. So algebraically, just need to clean this thing up a little bit. I'm going to get a common denominator here on the top. That's going to change me into, again, I have a plus positive here. The minus negative cancels. 4 radical 3 plus 9 over 12. In the denominator, I'm going to change this whole number 1 to 12 over 12. And negative 3 times root 3 is going to be 12 minus 3 root 3 all over 12. And my 12s cancel. Okay, so my final answer for this is 4 root 3 plus 9 over 12 minus 3 root 3. And yes, we do need to rationalize this. But I won't spend time in the video going through that. Just make a note that you do need to rationalize that to leave your final answer the way that it is. The point of this question in the notes, especially the whole thing, reason I wanted to go over this was to make sure that you could recognize this as a tangent of A minus B. Your A is this thing, and you draw a triangle based off of it. Your B is this thing, draw a triangle based off it. Make sure you identify which quadrants you're in, because that's from the chart above. We are restricting our domains here. Apply the formula, plug in the stuff, and then final answer should be rationalized, okay? I'll leave that like that. If you have any questions, bring them to class tomorrow. Thank you guys for watching. See you tomorrow.